talk about hemoglobin's function. We have been talking about RBC as hemoglobin. Let's look at how does hemoglobin transfer oxygen within the body. So if you can see, this is the grid where you have partial pressure of oxygen in mercury, mercury, so mmHg, and you can see the partial pressure going all the way to 100, which is saturated, right? And oxyhemoglobin, and this on the y-axis we are looking at how much of the oxygen is present in the within this hemoglobin molecule. At high oxygen concentration, oxygen binds to hemoglobin to form oxyhemoglobin. So you can see this is the hemoglobin, and it will absorb 4. Each hemoglobin molecule can absorb 4 oxygen. So at 100%, oxygen is set off in the arteries around the body. So it has 100% when it is in the arteries. And as it's traveling through the body, and within the body, we know respiration is happening and oxygen is being used up. Cells do not have enough oxygen. In those cases, when the surrounding area does not have enough oxygen, oxygen will be released from hemoglobin. As the blood flows through the tissues with lower oxygen levels, oxygen leaves oxyhemoglobin. And you can notice the color change. Essentially, by the time it reaches the capillaries and tissues, all the oxygen is given up into the tissue, leaving the hemoglobin to return to the lungs. By the time it gets to very low pressure areas in the capillaries, it has released all the oxygen. So now there is no oxyhemoglobin present. This hemoglobin or the RBC now becomes a carrier for carbon dioxide. So there are 3 ways in which it will be transferred. We will do this in a little bit, but essentially some of it will go and combine with hemoglobin. The other components will just dissolve in plasma. But essentially, from this point on, it's all related to carbon dioxide.